Okay, hey, whoever is watching, today I would talk about Poisson distribution. Actually, it will be about binomial first and how this turns up into binomial. I mean Poisson. So first, let's talk about binomial. So what is binomial? So let's say you are doing an experiment. You did it like n times, and you have two possibilities. You're actually testing, let's say, one certain event in an experiment. Either it happens or it doesn't happen. So you found out the probability of it happening is p, and the probability of it happening it is not happening is 1 minus p. So basically, so you do it 10 times. I mean, you do it 10 times and you want to check what are the chances that it will succeed small n times. So basically, probability that it succeeds n times after you conducted the experiment n times is given by this: n choose n times p power n and 1 minus p power n minus n. So this is the binomial distribution. And the thing is, so binomial distribution is really something else. I don't know how to say it. Like, uh, so let's say this is my x-axis and this is my probability in binomial terms. So I can only have discrete values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on. So the probability that it will occur once, the probability that it occurs twice, thrice, and so on, something like this. And always the probability, the mean, the mean of this distribution is equal to n times p. This is not approximation, this is an exact for result you get after doing the math. So now the question is, how does this thing approximate to the Poisson distribution? So how Poisson distribution looks like is something like this. So even I don't remember at this point. How did it look? I think it was something like this: lambda power x by x factorial e power minus lambda. Let me reconfirm it. Yep, we are good. Yeah, so, and this lambda is the mean of the distribution. So this is the Poisson distribution and this is a binomial distribution. Okay, how Poisson looks like, even this looks something like this. So the thing is, when n becomes large, a very large number, you know, very large compared to the mean of the distribution, the binomial distribution gets converted into Poisson distribution. So the most important formula I think here is this one: n factorial for large n is approximately equal to n by e power n. This formula is too good, it works so nice. So let me show you how nice this formula is. So I will do the graph. So let's say x factorial, this is x factorial, only the right side is relevant to us. And then we have x by e power x and times square root of 2 pi x. I mean, just look at it. This is so good. It's just so good. Not even just if you just cross the 3, it's good. Like it's perfect. It's the, I don't know. It just feels so good. Like I don't know who came up with this. It's I don't understand math well, but when I see the results, it is something else. Really, this formula is amazing, and this is the heart for us uh, in connecting binomial to Poisson. So let's see what happens. And why do we need Poisson? I think the reason is exponentials are easy to deal with compared to all this factorials, right? So why not if you can? Uh, and yeah, remember this is the main thing. So let's start. So how does this work? So first we will start off with binomial. So you probability of succeeding in n trials, given you did it n times. So it is n chosen p power n 1 minus p power n minus n, and now this will be equal to n factorial n minus n factorial and then finally it is p power n 1 minus p power n minus. And yeah, another thing, I might not even be able to derive it right now well. Not I won't be able to derive it well enough. If I can, then that's good. So mean of binomial distribution, I will use lambda for this, is actually n times p. It doesn't matter what binomial what the variable is. I mean what how many times the trial is taken, as long as it is binomial. This is the expression. This is the equation which governs it. So p will be equal to from here we can see that p must be equal to lambda by n. We will substitute it here, and also yeah, don't forget the Stirling approximation, that formula. So it will be n by e power n square root of 2 pi n divided by n by e power n square root of 2 pi n, and then finally it is p power n. No, I am substituting the p, right? It was lambda by n power n, lambda by n power n, and again I have to do it. I will do it again. 1 minus lambda by n power n minus n, and if you look carefully, all these e's get cancelled up. Oh, did I mess it up? Oh, I forgot this. Let me write this down as well. I will write it here itself. 2 pi n minus n. Only this e will get only cancel if also this term is there in the denominator. N minus n power n minus n by e. Yeah, now I will just cancel this up, and now let me write down the neater expression, which is not that neat but comparatively neat. And now square root of n by square root of n, and also n power n. So we have this done. Yeah, also this square root of 2 pi can get cancelled. I need a little more brightness. So yeah, let's, and now 1 by root pi, I will just write this as here 1 by square root of 2 pi. And then what more is there? Yep, that's it. Here we have this. I have lambda power n power n divided by 1 minus lambda by n minus n. Not to forget that I think lambda is way smaller than n, so n is way greater than lambda. So lambda by n is way lesser than 1. I think this is one of the crucial assumptions we are taking. So now all this crazy stuff. Where would we go with all this? Uh, okay. So n is very large. It's not infinity. I mean, n is just too large. Mm, and what else is there? I think I see too many n minus n, so let me just write this times n power n minus n because of this, mm, divided by n minus n power n minus n, so many n minus n's. Does if that means anything in this derivation, that's good then. So what more can I do? Mm, okay, and now I can what more can be done? Mm, I think I missed some terms as well. Let me write them down. Uh, n power n square root of n. Then what else is there? Mm, okay. Okay. Let's see. Is this the dead end? I have to see something up in the internet now, is it? Let me also check up the definition of exponential. Exponential is, as far as I remember, approximately equal to 1 minus 1 by n power n, right? When n is large. For a very large n, this is the thing. Let me just recheck it from Desmos. 1 minus 1 by 1000, I would say. 1 to the power 1000. No, not this. To the power 1000. Okay, maybe it was supposed to be a plus, but let me check. Yeah, it's pretty close. This is the approximate expression for Euler's number. So what is it for 1 by e? I think 1 by e I did it right. So 1 by e must be replacing it with a minus sign. Let me check. 1 minus 1 by 1000 1000. Yeah, yep, looks pretty good enough. So what would it be for e power any x? That's a good question. I think it is just well, I can just do this and nothing would change. But no, let's do something else.